Good afternoon, ladies and gentlemen. My name is Amalia, and such precious chance for me to be your MC this afternoon in our annual event, the third APCORISE 2020. First of all, let us say thanks to Allah, the one Almighty God, who has been giving us mercy, guidance, happiness, and health, so that in this event, although there are some limitations that make us have to hold the event online. Without any further ado, let's get directly to the second keynote this afternoon. I will now introduce the moderator who will lead this session. Please welcome Mrs. Amalia Suzianti, our respected head. The stage and time are yours, Mrs. Suzianti.
Good afternoon, ladies and gentlemen. Welcome to the keynote speech session with me, Amalia, as your moderator. Before starting the speech session, I will read the rules in this session. The keynote speech session will last for 55 minutes, 45 minutes for giving speech, and 10 minutes for question and answer session, where this session the moderator. During the keynote speech session, the slides containing the material will be shared to the screen by the operator. All participants will be muted during the keynote. Participants can't see other participants on this webinar, but keynote speaker and moderator can see it through the Zoom application. Participants who can press the raise hand button on the Zoom application after the speech session is finished in 45 minutes. Moderator will choose 3 participants to and incoming questions will be answered directly by the keynote speaker. Okay, I hope everyone has understood the technicalities of this seminar. Now, I will speaker at this session, Professor Dr. Holger Kohl. Professor Dr. Holger Kohl is Institute for Production Systems and Design Technology, IPK, the Director of the Division Corporate Management at Fraunhofer IPK Berlin, as well as for Sustainable Corporate Development at the Technical University of Berlin. He studied the business engineering at the Technical University of Berlin and at the School UC Berkeley. In 1999, Prof. Kohl joined the Division Corporate Management at Fraunhofer IPK as a senior researcher. Since then, he has initiated several national and international projects on intelligent manufacturing, strategic planning, knowledge management, intellectual capital benchmarking, and business process reengineering. He was responsible for their realization. Besides projects all over Europe, Prof. Kohl managed large-scale projects in Brazil, Indonesia, Vietnam, United Arab Emirates, Egypt, and China, and etc. His primary research interests are in the area of sustainable and intelligent manufacturing, strategic plan implementation of innovation system, intellectual capital management and benchmarking in both the public and private sector, as well as in the industry and service sector. I think that was the introductory session, and then I will let Professor Kohl to start the presentation. Prof. Kohl, the time is yours.
Yes, perfect. Thank you very much for the kind introduction. It's a great pleasure being today with you for the APCORISE 2020. As it has already been mentioned, I have quite some experience for sure with Indonesia. Therefore, sorry to all of you. I had the chance to live in Indonesia from 2000 to 2002 to work on a huge project for the Indonesia on reorganizing their national R&D system of Indonesia. And therefore, it's a great pleasure for sure to speak to you today about intelligent management for, in particular, customer-specific products. I'm not sure. I think I cannot push the slides forward, right? Ah, okay, you do this. Good. Okay, so first of all, maybe not all of you heard about Fraunhofer. So Fraunhofer is the leading and largest oriented research organization in Europe. We have at the moment more than 26,000 employees, which are based in 72 institutes. And our annual budget is about 2.6 billion euros. And what makes Fraunhofer very famous is that 2/3 budget is based on contract research for both the industry and also the government in terms of public funded research projects. As I said, we also have for sure quite some history with Indonesia. We had for many years a representative office based in Jakarta on Jalintam, and for sure very close cooperations to organizations like BPPT, LIPI, and for sure different ministries. In terms of we focus for sure on those topics which are very relevant for the German economy and which are able to answer the future needs of our industry and also of team. That's the reason why we work a lot on issues dealing with health and environment. You know, sustainability and sustainable manufacturing plays a more important role in most of the economies worldwide, for sure, including Indonesia. We work a lot on mobility and transport, communication and knowledge. So information and communication technology, knowledge management are also in the core research field of Fraunhofer, as energy as resources. For instance, you are all very well aware about the issue of rare earths, and for in particular the German electronic industry, rare earth is a resource. And that's the reason why we also do a lot of research, for instance, on how we can recycle rare earths and how we can rare earths in source loops. We also work on security and protection. We have a couple of defense institutes, and the institute I'm responsible is an institute which works mainly on research aspects dealing with production and supply of services, and at the moment, for sure, dealing a lot with of digitization and Industry 4.0. Next slide, please. In terms of our research output, you know, research isn't measured in terms of number of publications, number of citations, all those output-related R&D indicators. For us as an institute, for sure, the number of patents are playing a quite important role. Here you see that in 2018, we have overall more than 6,500 patent families active at the whole Fraunhofer Gesellschaft. We apply every year about 600 new patents. And with this, we already rank on place number 17 in terms of being the most active patent applicant. On the bottom, you also see, and we are quite proud of this, that Clarivate Analytics, Thomson Reuters has done this study about the top 100 global innovators. And Fraunhofer belongs in Germany to the 4 organizations are ranked under this group of top 100 global innovators. And besides very well-known brands and companies like BASF, Bayer, and Merck, is also ranked among this very prestigious group. So, in terms of our activities, you see here we have in Germany for sure our core activities with the 72 research institutes. But beside this, a couple of daughter companies worldwide. We have a daughter company in the United States, and in the United States we manage 7 research institutes together with universities. We have a daughter company in Latin America. We have a lot of project centers in Latin America, but also in other European countries and in Asia and Southeast Asia in particular. We have so-called representative offices, as we had for many, many years, a representative office in led by our very good friend, Dr. Ida Bagus Kisava Narayana. For sure, the international activities for Fraunhofer playing quite an important role. About 20% of our research budget is already generated by international projects, and Indonesia is also a very strong partner for us in Asia. Here you see now the production sector in Berlin. It is very well known, and therefore I'm mentioning this, because in this building we combine two research tasks. We have the fundamental research, the University Institute for Machine Tools and Factory Management, and we have the applied research by the Fraunhofer Institute for Production Systems and Technology. And both basic research and applied research in the field of production, we combine here under one roof in the Production Technology Center. And we also have a very famous international study program here, which is called Global Production Engineering. And even some of the members of APCORISE who did their master degree here at our institute in Berlin. Briefly speaking about the different rules. So I'm responsible here for the topic of corporate management and sustainable corporate development. We are working a lot on virtual product creation. For sure, a lot of IT necessary for developing, in particular, customer individual products. Therefore, this aspect of product creation plays also very important role. Everything which is still dealing with milling, drilling, turning is for sure very important for improving the production. As automation technology, everything in terms of cobots, everything related to new levels of automation in the factory are also research task in our institute, and also joining and coating. So now let's speak a bit more in detail today's topic. So why are customer specific processes becoming more and more important, and what can it also by aspects of Industry 4.0? Here you see the development of how manufacturing has organized during the last decades and even centuries. You see on the bottom right, in 1850, so years ago, that we had a quite high number of product variants and a low output per variant. So this is exactly what is shown on the y-axis. And this for sure was based on the aspect that manufacturing at that time in the 19th century was mainly organized craftsmanship conditions. That means we had a lot of very decentralized and local small scale manufacturing, and there was no stock. The craftsman started to manufacture an individual product after the customer puts an order. Therefore, a quite high variety by in parallel a very low level of output per variant. This has changed tremendously until the middle of the last century, driven by the introduction of mass manufacturing. We all know that already in the 1910s and 1920s, Henry Ford introduced the assembly line for automotive industry. And you also see here on the picture on the bottom left, a saying of Henry Ford, like you can buy a Ford T model in each and every color as long as it is black. So a highly standardized product, but manufactured under mass manufacturing. By this, he was able to reduce the cost per product tremendously. So that means the product variety decreased a lot, and in parallel, the output per increased. And by this, Henry Ford was able to gain from the aspect of economies of scale. This has now changed again from the middle of the last century until today in terms of customer individual mass manufacturing. And today we even speak about the aspect of personalized products. For sure, production technologies at hand like additive manufacturing, 3D printing, which allows us to manufacture personalized product directly based on a model. So we don't need to develop specific tools for customer individual products. But if we look at customer individual mass manufacturing, you can also see that more or less each car today directly to the suppliers. Now I see that there has been a screen and the presentation is lost, but now it's coming back. Okay, perfect. So, but what you also, that the complexity for personalized manufacturing is very much increasing. So if you just think about manufacturing is organized in terms of production planning and control, in terms of the manufacturing execution systems, then we can assess that the current production planning and controls are not able to cope with the complexity of lot size manufacturing. The reason why we need in production, and that's the reason why we speak about Industry 4.0, which includes the horizontal integration of processes from product development down to customer use over all aspects of production and distribution. And finally, also the vertical integration. That means from the ERP floor will create completely on the shop floor. So
We have issue here, so we're trying to figure that out first.
okay, I can also share my screen.
Okay, that would be.
So just give me the right to change my screen, and then I can lead the presentation.
The operator is now still to connect. Okay. Now you have organization screen.
Okay.
What is it, right? Okay.
Can you see the screen? Organize itself. We don't have the top-down planning from ERP over MES down to the SCADA systems anymore. Now we even have their objective that the product is organizing the manufacturing for itself. This is what we call self-organized under the and China, or also Indonesia, are still focusing on mass manufacturing and the manufacturing of individualization of products is increasing tremendously. And an example on the right-hand side, you see that the Western truck producer, and they invested in China and developed a new plant. And at the beginning, they had the strategy to manufacture at 60 different variants. After a few years, they are now already manufacturing more than 800 variants. So of 65 variants every year. This is very interesting. So that means Industry 4.0, an increased flexibility in manufacturing, increased customer individual products is not only an aspect of, let's say, Western country Germany, it is even a very important aspect of countries in Asia and Southeast Asia. And therefore, we very much welcome the initiative of your government in bringing the strategy of making Indonesia 4.0 to the market. And we were also involved in a lot of discussions with the Indonesian government, how to implement making Indonesia 4.0 to the different industries. And at the end, I show you one example in China, where so-called innovation centers in showing the industry the state-of-the-art technology and even the transfer opportunities of intelligent manufacturing to companies in Asia and Southeast Asia. That means the required management functions we need to organize a 4.0 manufacturing are dealing with the operational planning, monitoring, and control, to transfer the data operational planning, monitoring, and control to the performance management. This is what we call the real-time management cockpits, to really analyze the current situation only of the factory, but even of the individual orders. From performance management, then we can start to improve the ordinary business processes, and we can, out of the existing business processes, reconfigure also our performance management. Integration of the configuration and integration in the business processes with the operational planning, monitoring, and control, and also the performance management are the intake of order-specific processes. This, I think, a lot of you have seen before. This is what we call the pyramid. That means the way how production planning and control is organized in terms of the different levels in production planning and control. Top level, we have the enterprise level and typical IT tools like ERP, enterprise resource planning, PLM, product lifecycle management, CAD, CAM, and also supply chain management. On the middle level, we have here typically the MES system for production control. This includes material management, performance analysis, human resource management, and so on and so forth. And on the lower level, then on the production level, on the shop floor level, we have sensors, our numeric control, robot control, and the individual PLCs. If we now look a bit more in detail at of the order-specific processes and the example of a customer individual order of a specific industrial pump, that most of the MES functions are addressed here. So if we just want that, let's say, a specific documentation to happen in our assembly process, or if we want to have all rails from one supplier, then the function of management, the function of quality management, the function of planning and control, order management, data acquisition, and also information management are addressed. So it's not very simple to organize customer individual processes, because the MES systems and also systems very often are not able to cope with this increasing flexibility, complexity. Speak about the aspect of modular manufacturing. On the one hand, what helps us for sure achieve a certain agility in manufacturing is the presence of so-called digital twins. And here you see three levels of digital twins. We see on the top the information management twin. Then you see the production twin. So that means the factory, the real-time virtual factory. And then there's also the product twin. And also in the production twin, we have the machine. And this helps a lot in real time to have a proper mapping, monitoring, and also manipulating and predicting of manufacturers. And by this, for sure, we are much more able to address the behavior of connected enterprise objects. Objects in that sense, machines, equipment, humans, orders, and for sure, everything which is related to the aspect of information management. Here you see now what we understand under the compatible integration through one model. So we have on the top level for sure the strategic business objectives. They are referred to a business model, but also, business models which can be quite flexible. In today's time, under the Corona situation, we see that most of the companies are very flexible in terms of changing their business models. It takes weeks and months to adapt a business model at the end, and therefore we need a much stronger issue of flexibility in the corporate goals and also in the business models. Then we see here all the detailed business processes, and out of the business processes can then organize their operation and execution. But for sure, in terms of the real-time observation, back the assessment of the running operation execution to our business processes, and by this we can also adapt the business model, also adapt their strategic corporate objective. And all these information are stored in one central business model, able to even execute specific manufacturing processes. When we speak about the modularization, as I said at the beginning, it's not something new. Customer individual mass manufacturing, in particular of automotive industry, but also of many other sectors, has been by a modularization of the product. This is what you see here on the right-hand side. A very good example is Volkswagen. So Volkswagen developed many years ago the so-called product architecture, MQB. There is the front part of the car, there is the rear part of the car, and there are many other modules. There's a platform, and that means it is not so complex to manufacture customer individual products if we have a very modularized approach in terms of the product architecture. The same we see in terms of the modular factory architecture. So there are a lot of factoring modules which can be exchanged, and this allows a much faster ramp up by certain product changes, by, for instance, changing one model to another model. This helps a lot to reorganize the factory much faster and get faster to through the ramp up process. But still, the problem we see is the shop floor IT. We have a modular product, we have a modular architecture, but the shop floor IT is so far not modularized. And this is something I will also show in a that it's necessary to focus at the modular shop floor IT as well, besides the modularization of the product and the factory. So this is what you see here. On the left side, you see the modular factory architecture. And we were able here for one of our partners, for Audi, to develop a new approach of the modular shop floor IT, because with only 23 modules, we were the entire production chain from the press shop down to final assembly. So that means standardized business process modules which were able to be exchanged for specific individual orders, and this at the end led to the point that the adjust of the shop floor IT, the modular factory architecture, and here from some specific function, also from equipments and roles, we were able to develop a reference information system based on specific basic function, 23 individual modules which are able to be referenced to the blueprint factory. For instance, here the CKD, completely knocked control, and also the machine control, and then to realize the IT realization much faster. The used language here is USDL, Unified Service Language. What you see here are the structure of these 23 modules covering the production chain. There are a couple of standardized interaction functions, 5 overall, 2 trigger single release functions, and also 2 handle functions and 1 function for visualization. Then there are different functions for the information tasks. And finally, the new modules in terms of to take something out of the box, for instance, a transport module, a handle module, identification module, manage it, and so on and so forth. So with these 23 modules, we were able to nearly define the whole shop floor IT offer automotive assembly process. And that was the proof of concept we did here with an example of automotive industry, that we could say 59% of all processes can be completely covered by the standardized modules. Only in very cases, some specific modules need to be designed, but overall, most of the modules in terms of the shop floor IT processes standardized. And this allowed 80% reduced effort for the IT specification, and by factor 16 reduction of complexity. We already showed this on the Hannover. Unfortunately, the Hannover Fair this year with the partner country Indonesia has been postponed, and we already had a lot of discussions how to include Indonesia also here in our activities in Fraunhofer at Hannover Fair. But for sure, we hope that this will happen then in the near future. So therefore, you are very much invited also to visit us on the Hannover Fair, hopefully next year, to get more impressions about the aspect of production. So here's now a simple picture about the modular architecture in terms of how to control individualized processes. You see here on the top left, the reference model in terms of the specific production modules. Individual production modules are based on work plan container, and new modules can be derived, but normally the necessary modules are all stored in this on the MES level. Then there is a configuration of a work plan for a specific manufacturing task. by a customer individual order. This leads to a production order and the production process. And based on the individual configuration of the management cockpit, based on the individual modules, and based on the feedback from production by machine data acquisition and factory data acquisition, we can have a very, very good overview on the current situation of the factory itself, but also on each and every customer. This is the integration of the process view down to the organization of manufacturing by the MES level under Industry 4.0 aspects. Another important point is how to bring such approaches to small and medium enterprises. What we also developed in the recent years is a so-called Industry 4.0 Suitcase. It's a small box carrying standard equipment, and this can be directly attached to machines and equipment in small and medium-sized enterprises, and this allows to do a very first step towards Industry 4.0 with small investments. So there is even a tool for cloud connection. There is a small cockpit included. There are specific sensors included, wireless T. There are standardized quality services included, auto ID technologies, and also the aspect of the model-based configuration as mentioned before. A very simple approach, a suitcase with standardized tools to help the small and medium-sized enterprises to do a first step towards 4.0. Good. Let's have a brief look at the outlook, what we see as very relevant. So you have seen before that we are already able to have a modular product architecture, a modularized factory, and also a modularized shop floor IT. We now see that a next aspect might be area of even having modular machine tools and reconfigurable machine tools. That means based on a specific task, the machine tool can also be reconfigured. You see this here. There are specific lightweight elements, and a large scale machine can be reconfigured maybe to a smaller milling machine. And we already have such a prototype ready. It needs to be first. So a next step we see even in the modularization and configurable machine tool development. Then based on the production module, based on the specific machine configuration, which will come out of the order specific, the machine tool can be reconfigured and adjusted. This is something we are working on at the moment. To help bringing such approaches to the industry, here you see a project we are delivering in China already since 4 years, the development German Intelligent Manufacturing Research Institute. I had the chance to sign the contract for this with the mayor of the city of Nanjing in the Jiangsu province in the presence of and also Prime Minister Li Keqiang. And here we are working on a joint innovation center to combine Germany's technologies and also to bring such approaches to the local industry. Developing, therefore, a demonstration center for 4.0, a training center, a learning factory to allow interactive training of floor, but also for middle management and top management, and finally an application center which allows the development of individual solutions for the local industry. An approach we already pre-discussed with members of the Indonesian government, and for sure we hope to have the chance in the near future also to support in the development of such innovation centers and training and demonstration centers to showcase the state of the art of intelligent manufacturing to the most important sectors of Indonesia, as they have been detected and defined by the Making Indonesia 4.0 from the Indonesian government. Okay, thank you very much for listening. I know a lot of topics in such a short period of time, but now we still have 10 minutes for questions. So until 10 o'clock, I would be available for feedback, questions, and answers. Thank you very much.
Okay. Thank you so much for the very interesting presentation, Prof. Kohl. Now we will start question and answer session. Anyone from the floor would like to ask questions? Okay, from next one we have questions here that okay, that was very interesting. Yeah, I want to know what will be then the key success factors when you would like to. Sorry, I have to start my video. Sorry, I forgot. Okay. So what will be then the key success factor for starting the implementation of a modular software or modular architecture for the production process? Maybe you can share a little bit referring to your maybe experience with China, this project what you have already explained before.
I think what is very important at first to understand how the customer demands are already increasing, demand for the flexibility in manufacturing, and also to understand what are, let's say, the first steps to increase the opportunities in, let's say, even efficient manufacturing of more and more customer individual products. We analysis and we found out that by applying Industry 4.0, we can even reduce the production cost by about 20%. For sure, there is not the question per se to say we need to make our complete manufacturing process as individual as possible, depending on the specific sector, the specific industry, and the specific products. So for, let's say, process industry, Industry 4.0 is different interpreted as for serial manufacturers. You know, in process industry, if oil and gas industry, or sometimes even pharmaceutical industry, not have customer individual manufacturing. But for sure, in terms of getting good ideas about the current situation of specific machines and equipment, aspects of condition monitoring, and by understanding what is the most critical process within the manufacturing, for sure, detailed solution for Industry 4.0 might help. So that means at first it is a clear understanding about the strategic objectives and also the customer demands and the competition of specific specific competitors, and then a very clear planning, a so-called digitized manufacturing. For not each and every company, it is a must to invest billions. There are a lot of very small solutions which help a lot to, let's say, increase the capacity utilization, because failure times, unplanned downtimes can be tremendously reduced.
Okay. Maybe we also want to know or to hear your personal opinion about our national level policy for industry is Making Indonesia 4.0, because we have selected specific industries such as food and beverages, chemical process, and textile. Do you think it's already the right strategy or the right choices for us when you see the competitive advantage of our industry?
Yeah, I think I read the whole and I think it's very interesting and it has a very clear focus, and I also think that the sectors based on the given data has been well chosen. But the most question is, hundreds of countries in the world have an Industry 4.0 strategy. The question is how it can be implemented. And the industry cannot implement it by itself if there are not examples and role models. Therefore, we need the showcases to show the businesses that the investment in the upgrade of processes is real, that there is a return on investment, that maybe even the international competitiveness can be tremendously increased by this. Therefore, to have a strategy is the first step of many. The reason why we started the discussion with Indonesia to help Indonesia in terms of how to implement this strategy. That means, for instance, an innovation center which has been addressed in the Making Indonesia 4.0 strategy. Good. Maybe one question?
Okay. Okay, and then do you think also we need to maybe measure the maturity level of each industry, and then maybe start with that, and which industry already has the better maturity level of Industry 4.0, and then focusing at this industry first, and then continue the others?
Yeah, I have a very individual opinion on this because I'm not a friend of maturity levels. Because the maturity level would say that each and every company has at the end a certain or a quite similar maturity. And as I said before, this is 100% individual. For each, we are developing so-called Industry 4.0 white papers to really understand what kind of specific 4.0 needs they have. We cannot say, and every company, the maturity level 10 needs to be achieved. And therefore, I'm personally not a big friend of this, of such very standardized approaches, because it really needs to be done individually per case, from case to case. And as I said, for series manufacturers, it is completely different compared to lot size one manufacturer, completely different to process industry, and so on and so forth. There is no one and only maturity level.
Okay, thank you so much for your.
No. Yeah. Thank you very much for listening. Unfortunately, I have to leave for the next meeting. I wish you a great success of your conference, and hopefully next able to join the conference in person.
Okay, thank you so much.
Thank you. Terima kasih. Terima kasih.
Udah ya?
Okay. Thank you very much to Mrs. Suzianti and Mr. Kohl for the very insightful session. I'm sure that it was very useful for all of us. Now, we have arrived at the end of the session, and for participants who will be doing the presentations in session C, you are expected to join immediately through the link was sent to the WhatsApp group yesterday. I would also like to remind you that the names of presenters in session C can be seen on the screen. And I would like to ask everyone before we leave this meeting, turn on your cameras because we will have a group photo session. Okay. Okay, now that we are all here, I will count from 3 to 1 for the photo. 3, 2, 1. Okay. More time. Okay. I will count from 3, 2, 1. Nice. Okay. Thank you very much, everyone. Finally, as the MC for today, would like to excuse myself to close this session. Thank you for your time and see you at the next event. Now, all participants are allowed to webinar immediately. Thank you.